Alright, so question 25 is an annuity due because they're paying their investment at the beginning of the year. That's how you know it's annuity due. And you don't know how much you're paying each year, but you know it's 10% compounded annually, so 10 over 0.10 over 1. And n is m times t, or 1 times 8, or 8. Okay, so you plug in everything that you know, crunch everything down, and you get 12.5 equals r times this, divided by 12.5. And you get this guy. So when you plug in everything you know, you figure out this guy to the 8th, whatever it is, and then subtract 1, and then divide it by 0.1, then multiply it by 1.1, and you get this 12.5 number. Divide both sides by that, and you get your 3974. 35 is another annuity due. How do we know that? Because it says they contribute each month at the beginning of each month. So that tells you it's an annuity due. They want $180,000. 12% monthly, so it's 0.12 over 12. N is 12 times 18, because it's 18 years and compounded monthly. So N is 216. So you plug in everything you know. Again, crunch this guy down, then subtract 1, and then divide by 0.01, then multiply by 1.01. You get this guy and divide both sides, and you get 235.16. 37. Jane deposits $1,500 into an account at the beginning of each 3 months. So you know it's annuity due when they use the words beginning of each month, 3 months. It's 9 years, compounded quarterly, so 4 times 9. It's 8% quarterly, so 0.08 over 4. Okay, so you plug in everything you know and you crunch it down and you get 79,551. 39 is sinking fund is established by a working company so that they will have $60,000 in the future. If they make deposits at the end of each month, so you know it's an ordinary annuity. Compounded quarterly for 10 years, so it's 4 times 10. 12% quarterly, so it's 0.12 over 4. Gives you that number. So you got everything you need to know here, and you get 75.4 something. Divide both sides by that, and you get 795.75. Okay. 42 is a tough one. 42 says, suppose a young couple deposits $1,000 at the end of each quarter into an account that earns 7.6% quarterly, so 0.076 over 4. And it's quarterly for 8 years, so 4 times 8 is 32. So you plug in everything you know and you get this. After those 8 years, they start a family and find that they can contribute only $200 per quarter. They leave the money from the first 8 years into the account and continue to contribute $200 at the end of each quarter for the next 18 and a half years. So you've got two problems here. You're starting with this amount, and it's growing at this rate, okay? But you also have an annuity at the same time of $200. It's growing for 18 and a half years, and you get this much. And these two are growing at the same time for that 18 and a half years. The money that they parked in this amount is just going to grow on its own like a compound interest problem. But the amount that they're putting away at $200 a month, that's going to grow in a different way. That's in another annuity, and you got to do a new annuity at $200. So you got your compound interest and your annuity that are both growing, and you add them together. 43. A small business owner contributes $3,000 at the end of each quarter. So quarterly, 8%, so 0.08 over 4. Quarterly, so that's 4 times T, and we don't know what T is. He wants to have $150,000 at the end. Alright, so you know it's a regular old annuity, and the only thing you don't know is T, so you plug in everything you know. Again, you want to get this guy all by itself. So you divide by 3,000, multiply by 0.02, subtract 1, or add 1, sorry. And then rewrite it with log. So log base 1.02 of 2 equals the exponent for t. So write this with change of base. divide by 4, and now you've got your time, 8.75 years or 35 quarters. Actually, you could probably, no, that's 35 quarters. Yeah. Then part B says, suppose the account reaches $150,000. Business owner increases the contribution to $5,000 at the end of each quarter. What will be the total amount after 15 more years? So again, you got two different amounts of money. One, you've got an annuity at $5,000 for 15 years, and the other one is just straight amount of cash that you dropped into a compound interest problem, $150,000. So $150,000 is growing using typical compound interest problem, but you also have an annuity going at $5,000 every quarter. So you get two different amounts that are growing, and the two of them add together to give you 106 or 1.06 million actually.